Hello everyone, welcome back. So in this video, we will discuss the problem coverage of all zeros in a binary matrix. So given a binary matrix having n number of rows and m number of columns, and your task is to find the sum of coverage of all zeros in the matrix, where the coverage of a particular zero is defined as the total number of ones around a zero in all the four directions: left, right, up and bottom. So let's see this example. So here in this case, this is the matrix of size 3 cross 3 will be given to you. And here you have to find the sum of coverage of all zeros. And for every zero, you have to count the number of ones in all its four directions. So what is the coverage of this zero? So there is only one occurrence of one in right of it. So the contribution of this zero in my answer is one. Then for this zero, its contribution is two, 1 0 on the left side and 1 0 on the bottom direction. Then coverage of this zero, again only 1 0 on its right side, so plus 1. Then coverage of this zero is 0 because on the top of it we having 0 and on the right of it we are having 0. And for down and for the bottom cell and the left cell we don't have any such cell. So plus 0. Then for this cell only one cell upward, so plus 1. And for this cell again only one cell, so plus 1. So this is equal to 6. So let's see what is our expected output. So the expected output is also 6. So if you haven't solved this problem, then again please pause the video and try to think of a solution. It's very simple. So for every zero, what I can do, I can just simply check for all the four directions. And if there is a 1, then I will simply increment my answer. Otherwise I will simply move to the next cell. So how to check for all its adjacent cell? So let's say the current value of cell is I comma j. So this is the current index of the cell. So the cell which is in the upward direction is having value I comma I minus 1. That is, take me to the previous row at the same column. Cool. Then on the left of it, take me to the previous column of the same row. So I and j minus 1. Then for the bottom cell, take me to the next row and the same column. So I plus 1 and j. Then for the right cell, same row, next column, I comma j plus 1. So these are the four cells we have to check for. And before checking the values, first check whether they exist or not, because there might be a case when you reach out of this matrix, which is not possible. So we check for these conditions, that whether they are within range or not, and if they are within range, then just simply check this its value. If it is 1, then increment the answer, otherwise move to the next cell. So here is the implementation. I have declared my answer with 0, then number of rows and the number of columns, then iterating over each row, and for every row we iterate over all the cells of all the columns. And here I is the row number and j is the column number. So if the value is 1, then I just simply continue because I wanted to know the contribution of 0. Now if the value is 0, then I will check for the left cell first. So this is basically checking the above cell I minus 1 and j. And if it is 1, then I simply increment answer. Then here I am checking for the cell below the current cell. So I plus 1 and j. If it is 1, then increment the answer. Similarly, I will check for the left cell and for the right cell. And finally, I will return the answer. So what is the time complexity of this solution? So before that, let me just try to submit this. So here the time complexity is n into m, as we are iterating over each cell and with performing some constant time operations. And the space complexity is O of n, as we are not using any extra space such as array string or something. Cool. So thank you so much.